Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue our lesson on Introductions to Scientific Programming in chapter 9. So we will learn about matrix algebra. Right, so before we proceed with our lesson, let us take a look to the objective of today's lesson. Right, so the first objective of today's lesson is to introduce several matrix algebra functions to solve engineering problems. And the second one is to understand on how to use matrix algebra function such as dot product, cross product, inverse, and also determinant. And the third objective is to introduce other metric functions that can be useful in solving engineering problems. So basically what you will learn today is all about the matrix product. Okay, dot product, cross product, all of those matrix algebra functions. Right, so without further ado, let us proceed. So the first part of our lesson is all about matrix algebra. So in MATLAB was originally written to provide an easy-to-use interface to professionally develop numerical linear algebra subroutines. So in MATLAB, it has an very easy to use interface, so you can use the matrix algebra easily. Alright, so in MATLAB it also offers a wide range of valuable matrix algebra functions. So in MATLAB there are several matrix algebra functions that you can use, and you can applicate those matrix algebra in order to solve the engineering problems. So note that while MATLAB supports n-dimensional arrays, matrix algebra is defined only for 2D arrays, that is vector and matrices. Right, so as you all know, MATLAB it is supporting like 3D arrays, right, 4D arrays, and so on. But for matrix algebra, it is only supported for 2D arrays, which is vectors. So vectors we have two, right? We have a column vector or we have row vector, and we have matrices. So vectors is all about either we have one rows or either we have one columns, or matrices we have multiple rows and multiple columns. So all of vectors and matrices must be in 2D in order for it to compute the matrix algebra in MATLAB. Right, so matrix algebra is used extensively in engineering applications. So later on when you applicate or when you practice your applications of engineering in the future, so you will realize that matrix algebra it is widely used in solving engineering problems. So it is very beneficial for you to learn about matrix algebra by using MATLAB, so that later on you will be able to solve the engineering problem easily by using MATLAB. Right, so the difference between an array and a matrix, okay? So the first difference is most engineers use the two terms interchangeably, right? So they are either they wanted to use array or either they wanted to use matrix, so they can use it all together. Alright, so the only time you need to be concerned about the difference is when you perform matrix algebra calculations. Alright, so in matrix algebra you need to be concerned about array and matrix. Okay, so in this chapter you need to be concerned about the difference when you compute your answer to the engineering problems by using matrix algebra. So later on you will learn about what is the difference between an array and matrix and what are the importance of both. Okay, so next is matrix algebra solutions. Right, so first we will learn about some of the solution of matrix algebra. Okay, so the first one is dot product. Right, so dot product, when we are learning mathematics, it is symbolized by symbol dot. Okay, and then the second one is the cross product. So cross product in mathematics, it is symbolized by a symbol x here or symbol multiply here. Okay, and the third one we have inverse, and also we have determinants, and also lastly we have linear equations. Right, so those are all of the solutions that we have for matrix algebra. So in order for us to solve the question for matrix algebra, right, so you have all those 5 alternatives. Okay, so you can use either one, okay, in order for you to solve the matrix algebra. So it is depending on the question itself. Right. So for the first part of today's lesson, we will learn about dot products. Okay. So what is actually dot products? So the dot product is actually the sum of the results when you multiply two vectors of the same length together, element by element. Okay. So in dot product, it is actually when you multiply the elements together and you sum it up. Okay, and you sum it up, and then it is called the the dot product. Okay, so let's take a look at example 1. Right, so in example 1, we have two, we call it vectors. Okay, right, so this is 1 times 4. Okay, and this is also 1 by 4. We have variable u and we have variable v here. Okay, so when you dot product u dot v, okay, so you need to make sure that the first matrix, okay, it only has one rows. Okay, so for example this one lah, right, 3 2 6 4, it only has one rows. And for the second part of the dot product, it must have only one column. Okay, so if you have this kind of matrix, so you can successfully execute the dot products. Okay, so in mathematics, dot product is represented like this. Okay, 3 times 4 here, and then you add it with 2 times 3, and then you add it with 6 times 2, okay, and then you add it with 4 times 1. Alright, and then you add it together and you will get only a scalar answer. Right, so you don't, for a dot product, you don't have like a matrix answer, you only have a scalar answer. Okay, so this is the dot product representation in mathematics. Right, so in MATLAB, either matrix multiplication operator, so you can use star operator here, okay, or you can also use a function called dot to perform the dot product. Okay, so you have two options, either you want to use star here, or you want to use a function called dot here. Okay, so you have two options in order for you to compute a dot product. Right, next is using the star operator as a dot product. Right, so when performing matrix multiplications, the number of columns in the first matrix must equals to the number of rows in second matrix. Okay, and to apply the matrix multiplication operator as a dot product of two vectors, set the vector as below. Right, so if you wanted to apply the matrix multiplication operator, which is star here, as a dot product, okay, when you are choosing the star symbol as a dot product, you need to make sure that you have this kind of architecture for your matrix. Okay, for the vector lah, we call it vector. Right, so the first vectors, you must have the size of 1 for the rows. Okay, the rows must equals to 1, and then times by the column. It doesn't matter lah how many columns that you have. Okay, but you need to make sure that the rows is equals to 1, and then you have the star operator here, and then the second part of the vectors, you must have like a multiple rows, and you need to make sure that you only have one column. Okay, so for the architecture of star operator as a dot product, when you are using the star operator to compute your dot product, you need to make sure that the first part of the vectors must have only one rows. Okay, and the second part of the vectors, you must make sure that the vectors must have only one column. Okay, so that is the organization or the things that you need to ensure in order for you to using the star operator as a dot product. Okay, so you need to make sure that those condition is being fulfilled. Right, so that your answer will be correct. Okay, so note that the first vector is a row vector and the second vector is a column vector. Okay, so this one is what we call a row vector because it only has one row, and this one is the column vector because it only has one column. Okay, right, so let's take a look at example 2. Okay, so for this example 2, this example says that a formula to compute angle between two vectors, vector u and vector v, is as below, where the numerator of the inverse cosine is a dot product between the two vectors, while we will call it magnitude u and magnitude v are the magnitude of the vectors. Okay, so this formula, it is used to compute the angle theta equals to cos inverse u dot product v divided by the magnitude of u dot with the magnitude of v. Okay, and the formula of the magnitude is given as below. Okay, so for example, the magnitude of u equals to the square root of u1 squared plus u2 squared plus until you reach the end of the un squared. Okay, so the squared operation here, it is equals to u dot u prime here. Okay, because you change the rows to the column, you interchange the rows with the columns in order for you to have the in order for you to fulfill the conditions of the dot product. Okay, and the power of 1 over 2 lah, because it is square root. Okay, so this one is equals to this one. Right, so the question asks you to write a MATLAB functions to compute angle between the following two vectors. Okay, so you are required to write a MATLAB functions to compute an angle between the two vectors. Okay, so vectors u are provided and vector v is also provided. Right, so let's take a look on example 2 on how you want to solve the problem. Okay, right, let's do the example. Okay, let's minimize it first, open MATLAB. Right, okay, for example 2, so as usual, we need to have like functions. Okay, alright, so we need to make a new script first as usual. Alright, and then you can create like functions. Okay, function theta equals to, okay, vector angle uv. Okay, so this function will accept two inputs, okay, which is u and v, right? And then it will calculate the theta based on the input given lah by u and v. Okay, right, so before that we can save it as example 2. Okay, we don't have to put space here, we can't put space here. Okay, right, so the function to calculate the theta, right, the input is u and v, and then the second part is u magnitude. Okay, how to compute u magnitude, you can refer to the slides. Okay, right, so u magnitude equals to square root, so in MATLAB square root you can just use sqrt lah, right, in bracket u multiplied by u transpose. Okay, because we wanted to make sure that the first matrix only have one rows and the second matrix only has one columns. Okay, because the matrix that has been given in the question just now is 1 by 3 matrix. Okay, so this is 1 by 3 and this is 3 by 1, so it fulfilled the rule for you to use the star operator here. Okay, right, so that is u magnitude, and then we have v magnitude equals to square root, okay, v, okay, dot product with v transpose, okay, semicolon, and then that is for magnitude. Right, so next is the dot product for u and v. Okay, when you goes to the, what do you call this one, okay, u dot v multiplied by the magnitude of u dot magnitude of v. Okay, all right, so let's go back to the MATLAB. Okay, so next is what you have to do here is that, okay, right, u dot v, okay, u dot v equals to u star, okay, star, you are using the star operator here, v must be transpose. okay, so that you will be able to compute the dot product, because it is given the the u equals to, for example, 3 4 1, okay, and v is equals to 1 1 1. So this is the matrix for 1 by 3 and 1 by 3, okay. So you need to make sure that the size is correct for you to compute your dot product, okay. And then you calculate the theta equals to, alright, so in MATLAB for inverse cosine, you can put it a cos, okay, a cos u dot v, okay, here, alright, divided by u magnitude, okay, and then we can dot product with v magnitude, okay, alright, and then okay, alright, so because this one is already in scalar, alright, for dot product, this product will become scalar, this product will become scalar, and this product will become scalar, okay. Right, so theta, so we convert to degree, okay, theta degree equals to, because in MATLAB, basically the general the general theta that will be calculated, that is in radian, okay. So we usually use the degree, okay. Theta degree equals to theta, which is this one, multiplied by 180 over pi. So pi is constant, right? Constant in MATLAB. And then as usual lah, you print f, a typo here, f print f, okay, and then you start with the theta here, okay, theta slash x3b8 equals to, we have one identifier here, okay, percentage dot 2f, floating point, 2 decimal places, okay, slash x3co, so x3co is pi, okay, as you have learned before, or we have the second identifier, percentage dot 2f, float 2 decimal places, slash xb0, okay, xb0 is degree, okay, and then slash n, which is the new line lah, right. And then next is you describe what is the first identifier, what is the number that you wanted to refer to, okay. So the first is all about theta dot pi, okay, and then the second identifier is the theta in degree, theta degree. Okay, so this is the answer for the example 2, okay, as you can see in the slide. Alright, so basically we create a function called what they call vector angle, okay. The input is u and v, okay, and then you calculate the magnitude by using the dot product, okay. So in order for you to compute a dot product, you need to make sure that the size must be matching, alright. So that's why you need to transpose the second one, okay. So it is depending on the type of the matrix that has been given, okay, because we are giving u equals to 3 4 1, okay, and v equals to 1 1 1. That's why you need to transpose the second matrix, okay. But if you are given the matrix of 3 4 1, okay, we have semicolon here, alright. So this one, the matrix is matrix equals to 3 by 1 matrix, okay. So this is also equals to 3 by 1 matrix, okay. So for that, you need to make sure that your matrix must be similar to the rows that has been given in the slides earlier, okay, where you need to make sure that 1.3 matrix dot with 3 by 1 matrix, okay, for example in this example lah, for example, right. So because it is given 3 by 1 matrix, so you need to transpose u, okay. right? So U transpose, okay, multiplied by V, okay? So U transpose will be U, because U, the normal U, the size is 3 by 1, okay? And when you transpose it, it will become 1 by 3. So you need to make sure lah what is the correct input to your dot product is if you wanted to use the star operator here, okay? Alright, so this is the answer for the example 2, okay? So we go back to our slide. Right. Okay, so if you input these functions and then you give the input here, okay? Right, you give the input U 341, V equals to 111, and then you put theta equals to, you call the function of vec angle, okay? And then UV, vec angle, and you input UV lah because you have UV here. And then you will get the answer theta equals to 0.14 pi or 25.07 degree. Okay, so the first and second dot product apply a transpose to its second term to fulfill the size comparability. So as I've been mentioned to you earlier, okay, so you need to make sure that what is the size of the vector or the matrix that you wanted to give to your function, right? So from there, you need to modify inside the functions in order for you to fulfill the size comparability of 1 times n dot n times 1. Okay, so that is the MATLAB dot product. Okay, right. So next is the star operator is not always a dot product. Okay, so you must make sure that if you wanted to use star operator as a dot product, you need to make sure that the size, this kind of size is being fulfilled. Okay, so other than this size, the star operator will not return a dot matrix. Okay, so if you wanted to compute a dot matrix and you use star operator, and then your matrix is not in this size, so you will return wrong answer. Okay, right, for example, this one, you have U, okay, let me write it up a little, okay, right, so you have U here, right, the size of U is 1 times 3. The size of V here is also 1 times 3. Okay, and then what you did here is that you transpose it, so it will become 3 times 1, and then you dot product with 1 times 3. Okay, so when this situation is happening, okay, as you can see, this is not fulfill, what you call not fulfill the rules of dot product. Okay, because the rules of dot product, the first matrix must has only 1 rows, but this one we already have 3 rows. Okay, so if you are not fulfilling the rules of dot matrix, you will get this answer. Okay, this answer is wrong because dot product only return a scalar. Okay, a scalar, it means that only one value lah. Okay, it doesn't have any matrix size. Okay, not a matrix. Right, so you need to remember, okay, when you are using the star operator as the dot product. All right. Okay, so when the first vector is a column vector, okay, let me erase it first. Okay, all right. Okay, so when the first vector is a column vector, as the above example, it can be used as one of the solution to the vectorizing methods covered in chapter 4. So you can take a look back on chapter 4 on vectorizing. Okay, so the first vector is a column vector as the above example. It can be used as one of the solution of the vectorizing methods covered in chapter 4. So note that in chapter 4, array operator is used for vectorizing methods. So if you wanted to vectorize your matrix, you can use these methods. But if you wanted to compute the dot product, you cannot use these methods. Okay, you need to make sure, like as usual lah, the size must be correct. Right, so if you wanted to do vectorizing, you can use these methods, U transpose multiplied by V. Okay, but if you wanted to use dot product, you cannot use this because the size hasn't matched. Okay. Right. So next is the star operator is not always a dot product. Right. So let's recap. This is example 4. So in example 4, let's recap example 16 from chapter 4, where a formula of compound interest B is evaluated for 3 values of A. Okay. $100, $500, $800 on 5 different total year of N, which is the year lah. Okay, and R equals to 0.09. So instead of the array operations, the array multiplications can be replaced with matrix multiplication as below. Okay, so if you are given 3 input, right, A, N, and R, okay, and then if you are using the array multiplication where you learned earlier lah in chapter 4, you need to have a mesh grid. Okay, you need to compute a mesh grid. Mesh grid is actually like a duplications of the matrix of A and the matrix of N in order for you to do the array operation. Okay, because array operation you need to have matrix with the same size. Okay, so in order for you to compute matrix with array the same size, you need to use mesh grid. Okay, but if you are using matrix multiplication, which is the dot product, okay, what you can use is that you need to make sure that the A, okay, you transpose it, all right, and then you multiply by 1 plus R, and then you dot the power of N. So you can just use matrix multiplication simply like this lah. You don't have to use mesh grid. Okay, so for the matrix multiplication methods, it is done on 3 by 1s multiplied by 1 by 5 size format, thus resulting a 3 times 5 matrix. Okay, so you will resulting 3 times 5 matrix for matrix N and matrix A. Okay, similar to the array multiplication methods. So since it only works for multiplication, the power operation is maintained with the array operation. So in this case, mesh grid is not needed. Right, so if you are using matrix multiplications, right, this is not a dot product. Okay, this is like a vectorization that similar to the previous example. All right, so you can use matrix multiplication in order for you to reduce the coding line lah. Right, so you don't have to use mesh grid. You can just directly use matrix multiplication, so it will automatically multiply the matrix for you. Right, so the result will be similar to this one. Right, so the next alternative that you have in dot product, you can also use the dot functions. Right, okay, so since the star operator is not always a dot product, dot function is a less confusing methods to perform the dot product. So if you I am a little bit confused lah about the star operator when we wanted to use it as a dot product. So I will use the dot functions because the dot functions only do the dot product. Okay, it doesn't do any other things. For example, in the previous example, the star operator does the dot product. All right, so if the size is not fulfilled, it will do the vectorizations and so on. Right, so it will be quite confusing lah for us. But if you are using the dot function, so obviously the name itself says the function, okay, it will do the dot product. All right, so it is simply as if you have U with this kind of matrix 1 times 3 and V with 1 times 3 product, so 1 times 3 vectors. So when you are using the dot product, it will automatically convert it into a shape where you can conduct a dot product. Okay, so dot you don't have to transpose it out. Okay, and then it will give an answer for you. Okay, so the answer must be in scalar. Okay, which is 8. Okay, so the dot function will do those things for you. Right. Okay, so let's take a look at example 6. Okay. So in example 6, table below shows the position of several components in XYZ coordinate together with the component mass. Right, so this is the index, and then this is the items, and this is the measurement, or I'm sorry, this is the position of the items, okay, and this is the mass of the items, okay. So this example, it is used to compute the center of mass, okay. This is the item, this is the location of the item, and this is the mass. And they wanted to compute the center of the mass of all of those items, combine it together. All right. So how to calculate it? We refer to this formula. Okay. So this is the formula on how to compute the center of mass position on the above components. Okay. For the x center of mass, x coordinate center of mass, it is actually x dot m okay, divided by the summation of mass. For y dot m, okay, y it means that all of this coordinate lah, okay, and m is all of this mass, okay. Y dot m divided by the summation of all the mass, okay. Z dot m, all of z coordinate dot product with m divided by all of the summation of mass. All right, so let's do this example in MATLAB. Okay, so right, so before that we start with the answer first lah, okay, and then we just like what they call, we verify it by using MATLAB. Okay, so from the equations, the x dot m, y dot m, and z dot m is a dot product operations. So let's rewrite the three dot product equation in matrix form by setting vectors x, y, and z into a single matrix P. Okay, so this is a single matrix P. Alright, so this is x, y, z, this is x, this is y, this is z. We arrange it together and we put it in matrix P dot m. Okay, because we wanted to compute manually by using mathematical rules. Okay, and then this is the first matrix and this is the second matrix. We compute the dot product, okay, and then you will get this answer. Okay, this is for x, this is for y, and this is for z. Right, and to get the center of mass, all right, d is divided by the sum of the mass. Okay, so this one, okay, it must be divided by the sum of mass. Okay, so this is the sum of mass, and then you divide it together and you will get the final answer of 0.87, which is the center of mass for x coordinate, 1.61, which is the center of gravity for the y coordinate, and the last one is 2.57, which is the center of gravity for z coordinate. So we will compute the MATLAB codes in order for us to solve this kind of problem, and we must get this answer. Alright, because we already compute manually and we get this answer. So in MATLAB, basically we need to get the same answer. Right, so let's take a look on the MATLAB. Okay, right, so for this one we just create a new one. Okay, we put it example 6. Okay, right. So from the table, okay, we are having the first data m equals to, okay, 3.5, 1.5, we have 0.79, we have 1.75. Okay, so this is data that has been given in the table. We have data x coordinate of all of those tools, okay, nut, screw, and so on. We have 0.1, we have 1, we have 1.5, and we have 2. Sorry, we have 2. Okay, you can refer to the slides or to see all of the coordinates. And we have y here equals to 2, okay, 1, 0.2, and 2. Sorry, 2. And then the last one we have z, okay, z equals to 3, sorry, we need to have a square bracket here, 3, 1, 0.5, and also 4. Okay, and then we have x bar here. Okay, x bar is like the one of the operator, okay, which is the dot product of x. Okay, so x is equals to dot product of, we use the dot function here, dot product of x and m divided by the sum of m. Okay, so in MATLAB, if you wanted to compute the summation of a number, okay, for example, the summation of m here, we have m matrix here, right? You can just use the sum function, and inside the bracket you just put the variables that you wanted to sum it out, right? Next is you have y bar equals to dot product, okay, y comma m divided by sum of m. Okay, and lastly you have z bar equals to dot product, okay, you dot with z dot z comma m, okay, you need to have semicolon here. All right, and then you divide it by, as usual lah, sum m. Okay, right, next is we wanted to make sure that our answer is correct, so you need to print lah your answer, you need to show your answer. Right, so f print f printf. Okay, all right, so you need to have like a, sorry, this is the wrong. All right, so you need to have like this one. Okay, you need to have a normal bracket and square bracket, and you can put it as center of mass. Okay, /n, new line. Okay, after the new line, x equals to, you have identifier here as for usual lah. You put percentage here, and we wanted to put floating number with 2 decimal places, and then new line, right? And then you have y here, y equals to another identifier. Okay, we have a little space here, dot to f, sorry, dot to f lah, because we wanted to have 2 decimal places. Okay, dot to f, 2 decimal places. Okay, /n, new line, and then z equals to as usual, identifier, percentage, dot to f, 2 decimal places. Okay, and then /n, which is the new line, and I think that is all for the things inside the fprintf. Okay, and then next is the things that you wanted to put inside the identifier here. The x coordinate of the center of the mass, y center of the mass, and z center of the mass. Okay, right, for this one, y bar, we have x bar here. Okay, y bar and z bar. Okay, we close the bracket. Okay, and then we can run. So as you can see here, right, the center of mass equals to x equals to 0.87, y equals to 1.61, and z equals to 2.57. Right, so you compute all of the what we call the center of mass for x, y, and z, just using the dot product here. Okay, and the sum dot function here, and sum function here. Right, so you can just solve it by using a simply or what we call a simple code. Okay, instead of you calculate it by yourself, you arrange it one by one and so on, but you can just calculate it by using a simple codes inside MATLAB. Okay, all right, so this is the codes. All right, so this is the graph, okay, that you can plot based on the information or based on the data that you have. Okay, this is the all of the things lah, all of the items that has been shown in the table, and this is the center of gravity. Okay, so this plot was enhanced using the interactive plotting tool. So this plot has been modified, the color, the type of line, based on the plotting tools, interactive plotting tools that I've been teaching to you last chapter, the previous chapter. Okay, so you can just compute this graph, okay, by using all of the information given. All right, and you can customize it by using the interactive plotting tools. All right, so the interactive plotting tools is already explained in the previous chapter, so you can refer to the lecture. All right, so I think that's all for our class today. Okay, so the second part of this chapter, all right, we will learn in the next class. Right, so if you have any question, you can just ask me in the Telegram group, and please inform me if you have any difficulties learning about this chapter. Right, so I think that's all for today's class. Thank you very much for your cooperation towards this class. Assalamualaikum and have a good day, everyone.